tutorial starts with a song, but it's only a few seconds long. Let's get started with animation. Hello friends, today we'll talk about pi, the number pi. It comes in the Greek alphabet after Omicron. Pi is important in everything which has to do with circles, with spheres, with rounded things. And I did tutorials about the number pi in context of creating a visualization of a circle, for example. Today we're gonna roll something with pi. Enjoy this trip. Let us start with a plane and with a sphere. You can use polygon modeling, whatever. I use curves and surfaces here, and this is going to be the plane. In the attribute editor, I have quite convenient numbers. The width is 1 and the length ratio is 1 as well. When we extend this to 10, we have a long stretch, exactly 10 units. 1, 2, 3, 4, 5 and 5 again, so it's 10. Right mouse click, I assign an existing material because I prepared a material. Now I create a sphere. And the sphere also in the attribute editor has something called a radius. And I want to make the sphere smaller, so 0.5 is just half of the sphere, so the diameter is 1. And I move the sphere over to the right because here I wanted to start with the motion, and here I want it to end with the motion. In order to transport it right, this time I use the attribute editor again, and this is the Z direction, this is the positive Z, so I need -5, which is -5 here, so the sphere jumps there, and I need to raise it by, well, obviously 0.5 units, so it's on top of that plane now, and I give it another color so we can see the rotation better. Now the typical thing to animate this is like this. You have a range of, for the animation, like 120 frames, which is just about 5 seconds, which is just fine. We start here and we give the sphere keyframes by pressing S. Lots of keyframes, even for the scale, which we don't actually need. I have auto key on. It's this icon at the bottom right. If you don't have it, you have to press S again and again. But in this case, with this auto keyframe tagged on, Maya recognizes when I change a parameter and sets a keyframe automatically. Sounds complicated, but it isn't. Now I go to the end of the animation, frame 120, and I move this sphere over here. Actually, I can move it with the translate unit to +5. And you see the keyframe is being set because of auto key. Now the animation goes like this. The sphere slides. Here you see the red sign is the x-axis, so in the x-axis we need a rotation. Now at the very beginning the rotation is 0, and at the end it's 0 as well, so let's change it here to say 360. That would be one full rotation. Now the sphere does rotate, but it slides, obviously. Let's go to the end of the animation and increase this maybe to 500. Is it getting better or worse? It's getting better, but it's still sliding. It's not precise. And the human eye detects that sliding motion, and this is not good for most purposes. You need an exact rotation. If I minimize this rotation here, to say instead of 500 to say 200, I get even more sliding. Okay, how can we calculate this? And here is where pi comes in. we need a mathematical equation for the surrounding of that sphere. Let's call it P. P is the perimeter. It equals 2 times radius times pi. That's the amazing thing about pi. It was detected, I think, 2,000 years ago, and pi makes that bridge between the XYZ world and the rotation world, the sphere. So 2 times r is the diameter, really. So it's the diameter times pi gives us the surrounding of the sphere, which is called the perimeter. In our case, we have a diameter of 1, and the number pi is an irrational number. That means it never ends, but the first digits are 3.1415, and so the perimeter of our sphere, of this sphere, is 3.1415, etc. In one rotation, the ball moves 3.1415 centimeters forward. That's what this equation about the perimeter and pi and the radius does. So when in one rotation the ball moves 3.14 centimeters forward, how many rotations does it perform for 10 centimeters, which is the whole stretch of our plane? Well, it's 10 divided by 3.14, which is roughly 3. So the sphere performs 3 rotations, more or less, from A to B. To be more precise, 3.18. Now the last equation we need to consider is we want to know how many degrees the sphere rotates within its path. And that is the 3.18 times 360 degrees, because 360 degrees is one rotation. And it equals, when you calculate this, 1146 degrees roughly. And this is the number we enter now into our rotation in X. Now let's have a look if the sphere still slides. And you see it doesn't. Now the principal thought is, of course, we don't have 10 centimeters. We don't have a sphere which is 1 centimeter in diameter. Our sphere is much smaller or larger, and the curve which it rolls on is much longer or shorter. So what is a generalized equation for this? So let's define 3 values. The rotation in degrees is r. We call the length of the path, in 10 centimeters in our case, L. The diameter of the sphere, in our case 1 centimeter, is d. And now the equation goes like this. R equals 360 degrees times L, the length of the path, divided by the diameter of the sphere times pi. Try it out. I did.